Welcome to our physics projects. Um, you won't probably see me much, I'm the editor. So please enjoy our pinhole camera video with, with my background music.
So let's start. The pinhole camera and its history. The pinhole camera is the first camera that have been invented into this world. The inventor of the pinhole camera is Alhazen from his experiment in the 10th century. That light itself comes from an outer source and not from the human's eye, which on that time they still believed from the great philosopher. And he also explained that light travel in a straight line, which will later be known as propagation of light principle in physics. The principal camera is also known as the camera obscura or the dark room. The pinhole camera starts off as an item for optical science for looking out for solar eclipses and stars, but later on the 16th century it was popular amongst artists and painters to help aid them with their arts. So let's start off. What material are we going to use? We are going to use a flashlight. We're going to use a paper that's shaped into an arrow or our image. We're going to use a lightproof box. In this we use a wood box that we craft on our own and create a pinhole in it. Then we will use a film or thin black paper that we can use to see our image through it in the result of a pinhole. So how does it work? A pinhole camera works on a rectilinear propagation of light, which is a physics principle as state that light travel in a straight line. First, we line out the image we would like to use. For us, we are using an arrow as our demonstration. So we will position it in the place you prefer. Different angles, different size of an object and image size result in a different result of it. Maybe you will get a bigger images in the pinhole or smaller images. So in this case, pinhole size also have an effect such as the sharpness and clarity. It also require a longer exposure time too, the smaller the pinhole get, because it allowed less light to enter the camera too. In this, after we are going to flash our light from the flashlight at the back of a paper arrow shaped like paper we made, as we are using light to capture the image. We will flash into our pinhole because when a camera points toward the scene, the light from the scene enter the pinhole. Light itself travels in a straight line path according to rectilinear propagation of light principle. The pinhole emit the light ray that pass through a camera and continue inside the camera. Then we would wait for a while for our result. It can be seen through the film. The result that we get would be the changes inside, which is relatively smaller and reverse of the image or an upside down picture.
Okay, for the calculation part, the formula for the pinhole camera is I over O equals to V over U, where I is the image size, O is the object size, V is the image distance from the pinhole, and U is the object distance from the pinhole. If we draw that out, we'll get this picture. So, if we were to apply this formula in our experiment, we have I equals to 4 centimeters, O equals to 6 centimeters, V equals to 21 centimeters, and U equals to 30 centimeters. These values are from the experiment, which we found out by measuring with a ruler. So, suppose we don't have one value and we want to find it, but we were given 3 other values. For example, we want to find I, and we were given O, V, and U. We can use the formula I over O equals to V over U, and then isolate I, which will get I equals to V over U times by O. Now we input the values 6, 21, and 30 in the corresponding variables. So we'll get I equals to 21 over 30 times 6. If we put that into our calculator, we will see that I equals to 4.2 centimeters. And that is quite similar to what we got from the experiment, which is 4. Now we also did another experiment by changing the image distance from the pinhole by increasing v. So we get I equals to 55.5, O equals to 6, which stays the same, V, which we changed from 21 to 28 centimeters, and U, which stayed the same with 30 centimeters. Now suppose we don't have the value O and we want to find it. We can use the same method, but by isolating the variable that we don't have, which in this time is O. So O equals to I over V times by U. Now if we input the values into the variables, we get O equals to 5.5 over 28 times by 30. If we put this into a calculator, we get we get 5.89, which is again similar to what we got from our experiment, which is 6. Another thing that we can get from this experiment is this graph right here, which means that the size of the image is directly proportional to the distance from the pinhole. As the distance from the pinhole increases, the size of the image also increases.
Conclusion. Pinhole camera has been around since the 10th century. Its impact in photography are the result of nowadays camera. The pinhole camera itself works on a principle called rectilinear propagation of light, or that light travels in a straight line. The pinhole camera works by flashing an image into the pinhole, which will result in a smaller and reversion of the image can be left to right or upside down. Because light itself travels in a straight line path, and when it gets to a pinhole, it also still travels in a straight line path. This results in an image that we can see through behind the film that will be relatively smaller because of our pinhole size. So hope you find this video helpful and entertaining. Have a great day.
That should be done with our physics projects. Thank you for watching.